So now we're gonna get back to work. Now today the goal will be to rewrite it to actually work, because the problem was last time last time the problem was that like the input was like not really great to edit and whatnot. So now I'm gonna rewrite it to work. So rewrite to actually, and I'll try a new one. Work. Cool. There we go. And yeah, now I'm gonna work on the rewrite. So step one, I'm gonna start up with. So I'm gonna open up the test file, right? And so we obviously have a single shape test. That's basically there's one shape in memory. We have a bounding box. RGB color is a rectangle, and then we're going to output it to the right spot, right? So this is what we have to do. Yeah. So yeah, and so from here, what we have to do is we have to. This is the intended goal for like having one bounding box, right? And so when we read from memory, we're reading a certain amount of addresses. So first, we give it the byte 1, byte 0. We are commenting out the need for byte 0 of the address. We wanted to output out byte 0 and 1 of the address, right? And then output enable. And then, we want output enable to always be on, right? But we're going to give it 2 bytes of the address, and then we're telling it to read write. We await the clock cycle, and we write the data in, and then we await the clock cycle after that, right? Cool. Now, from here, what we have to do is we have to keep going, right? So we have the write to memory. This should be the expected behavior. It's the same thing, and then we have the stuff we want, and we wait an extra clock cycle. Cool. Then I'm just gonna run the test code. Source. We have to activate the virtual environment, and then we run it, and obviously we fail. Cool. Now we're going to start with the rewrite. So SRC project.v. So obviously, a little bit of an insane bit of thing. So we should probably write this better, but we can deal with that later. So reading. So obviously we have a default state. This should probably be 4 states, right? Read shapes 1, 2, 3, and 4. 3, sure, 13, whatever. The exact number doesn't matter. Yeah. I can look at that after the stream. I'm just gonna focus on the stream right now. But yeah. And so, yeah. And so from here, 1, 2, 3, and 4. So on state 2, we will have these outputted. So I should probably rename these, right? So hold on. 2, 1, 0, and then so how many steps is state? 8 bits, 255. State 255. I'll call this starting state equals 255. And then we go 1, 2, 3. Cool. And so this will be the starting state. And then on state 1, starting state will go to state 1. State 1 will go to state 2. And then state 2 will go to state 3, right? Which isn't just an extra thing in the middle. So on state 3 we read. And then, yep. And this goes to state 3. Read num shapes 3. Cool. There we go. And then this, we delete the line, and this is just like a state where we actually do that, and then we go into the next state. Cool. And then we run this again. Where are we failing it now? Single shape test. Where? Hold on. Where is the line that failed? line 89 and line 21 is what failed. So when we're reading the next byte of the address, looks like that's when it starts to fail, which makes sense. Let's just let's add up some print debugging, right? So read from memory, print. Sorry, this is dude.log. It is under log, right? Oh boy. I'm just gonna assume so. Yeah. Under log. I can probably check this out. I can probably check this out. Oh my god, we got people here now. Yeah. CocoTB docs. Let's pull up the docs. Let's pull up the CocoTB docs. Let me make this a whole lot bigger. CocoTB docs. Writing test benches. CocoTB dot. This is an info message. Yep. Logger. CocoTB.log. Okay, sure. Print doesn't work. Yep. Okay. So logger equals logging. I'm gonna logger.get logger, not my test bench. It's oh, it's from no. It's I want to use dut.logs. Dut. What? I know this actually works. Hold on. Because here, if we go into the test, I'm just going to look at what I did previously. I'll look at what I did previously, and from there we will do it. And so, log. Hello? No? Okay. Did we get rid of all the print debugging here? Okay, looks like we did. Sure. Let's go to the template, and the template will have it in here. Yep. Underscore log dot info. There we go. There we have it. That's what we need. Dot info, and it's going to be we're going to log an f string, and we're going to log the memory. Yeah, the memory. Mem colon. And then this way we can find out when we actually fail. Make dash b. I forgot the value. Mem. What is mem? Oh, mem is a memory object. Mem dot. Oh, okay. We're reading 1 byte and then 4. That's how much we're reading, and so yeah, read from memory. Yep. Write to memory. Okay, sure. I'll have a nr equals 1 because that means we've read 1, and I'll have a num read, and it is going to be nr, and then how much num read is 1, and then we fail. There we go. Cool. So read from memory 1,4. Ah, and then here's the problem. Output value is byte 0, which is wrong. We are looking for 1. This is a great sign. Make dash b waves equals true. Let me delete the. Oh my god. Alright, let's go to CocoTB docs. Search waves. Environment variable. What do we want it to be? Waves equals 1. Yep, there's the VCD file. Cool. And then GTK wave. There we go. And so we will open up in a new tab. We will open up the VCD file. Cool. And so then I'm just going to dump it all in there. Yeah, cool. Yep, okay, so it's failing here. Why is it failing? So we enable it. The state goes from 0 to 1 here, and so it's on state 1. That means that we're reading, but we are reading... Okay, whatever. This is lagging a whole bunch. We are having a decent amount of lag. That's not great, but, you know, it is what it is. Yeah. That's... okay, sure. That's not great. Okay. Cool. Now we just have to... Okay, GTK wave is lagging. Okay, whatever. So state 1, and then what are we outputting? We're outputting nothing. Not great. So we enable it. Hold on, we should be reading 4 bytes from memory. So we start by attempting to read 1 byte from memory. Right, so how many shapes are there in memory? So this means that we should be reading the first bit. So since we're reading 1 byte, this is 1. So memory address is 0, and the address we're reading from is 0. Yup. Cool. And so we're reading from address 0, so we should have 0 on both of these. And output enable, and what is output enable? Is 255. So UIOE should be 255. UIOE, it is 255, like permanently. There we go. So during this state, we are outputting. In the next state, UIN. Why is UIN 1? That is a mistake. Yes, that's a mistake. Well, UIN data. So during state 1, we should be here. During state 2, we should be here. And then during state 3, we should be reading from it. Oh, we had to add a delay at the start. Okay, yep, that checks out. Read from memory. It's 08 clock cycles. We should just await this an extra 1. We're still failing. Cool. Now how is this going? Yep, we go a little bit longer before we start failing. So state 3 is when we read. And then we do have an extra wait on the end of that. What is the error here? The error is it still in the... Hold up. Is the error still in where I think it is? Byte 0 of the address is... Yep. Okay, so int, do you see that you will out the value byte 0 of the address versus byte 1 of... So we're attempting to read 1. Yeah, that checks out. This all checks out. So expecting 1 at the output here. So we let the clock go for this cycle, right? So we write this value in and we let the clock go for the cycle. What if, hold on, what if we just added a cycle at the start of this? nvim SSD party.v, cool. So we go read, so we go address in state 1, address in state 2, then we read in state 3, cool, so here we're reading. Then we're just wasting a cycle in bounding box 1, which is not ideal. So what if I just say, hey, wait, no, bounding box 1, we should be doing that. Right, and then in bounding box 2, we should be doing that. And then here is, in bounding box 3, we should be doing all the counter stuff. But let's just go through and figure that out. Yep, okay, there we go. We're going for even longer, there we go. So yeah, we just have to move all the stuff down, right? So that's what we have to do. In Vim project.v, we just have to move all the stuff down. So bounding box 2. Oh, and we also have to increment read address. Are we incrementing read address? Yep, we can set read address to 1. Yup. Increment the read address. Then we just keep going down here. That sets up the next state. Yup. I guess where that is doesn't matter particularly. This sets up the read. So this is what we do on bounding box 3, right? On bounding box 3, we write up all of this. So hold on, this goes down there. So there. Cool. And then if counter is, and so on the next one, so on bounding box 3, this is when we actually make the check, right? So if the counter is 3, so I'm just gonna bring that down here. If the counter is 3 on bounding box 3, we go to check bounding box, and we should be doing this stuff. Otherwise, we go back to bounding box 1, which I'm gonna paste in here. So now we should be checking the bounding box correctly, in theory. I need to change my ID to use space instead of tabs. That's the thing I have to do. Cool. How far did we get? We did not get further. Okay, where did it fail? Address 2. Memory address. We're outputting 0. Okay. So 1, 2, 3, 4, 5. This is, it's because we need another delay at the start, do we? Hold on. 1, 2, 3, 4, 5. So read shape bounding box 2. Hold on, what is state 5 is 3. So we are currently in bounding box 3. So we should be outputting, we should be reading at this state. And yet, well, that's UI in. Why is, no, state. That's state. So why is on state 5, right? Like, what are we doing here? So on state 5, it's, yeah, so on state 5, what's going on here is we're going on to the read shape bounding box. Hold on, this is probably better if I just diagram it. Right, I'm just going to diagram the states that we're in. So we're going to start in the starting state, right? Then we go to read num shapes. Read num shapes 1, and then I'll have each like individual thing on its own. Read num shapes 1, 2, and 3. Right, I'll start from the start here, and this is the state diagram. Right, so we always go to read num shapes 1, always go to read num shapes 2, always go to read num shapes 3. Right, so this all checks out. Then we go to bounding boxes, right? So read bounding box 1, right? Then we go to read bounding box 2, always. And then we always go to read bounding box 3, right? So we're going here. Then we have a check here. So we go back to read bounding box 1. If counter is less than 3. Otherwise, we keep going. Right? Otherwise, we go to next state, which is read shape. Hold on. Read shape bounding box. What? Oh, num shapes. Not bounding box. What? Yeah, num shapes. 1, 2, 3. Read shape bounding box. Yup. 1, 2, 3. And then we go into check bounding box. Right. Check if we're in the bounding box. Right. Check bounding box. Right. So this is, hey, are we in the bounding box or not? Right. And then if we number this, it goes. So this is state 0, 1, then state 2, state 3, state 4, state 5, state 6. Right? And so when we look here, the problem is that on state 5, what happens is we are not checking. So it goes state 1, 2, 3, 4, 5. On state 5, here, we are expecting the wrong output. What? Oh, I know exactly why. It's in the test. The test file has a delay here. I mean, we need a delay here. We need a delay at the end. There we go. Yup. Oh, hold on. I need wave files. Cool. There we go. Now we go for even longer. And so if I zoom out a bit, 4, 5, and then 1, 2, 3, 4, 5, 3, 4, 5, 3, 4, 5. What? 6. Hold up. Cool. Yeah, so now we need hold on. It is 3, 4, 5. Oh, it's 0, 1, 2. Okay, hold on, let me edit the diagram. State. Whoops. 255. Then we go state 0. State 1. Then we go state 2. Then we go state 3. And then state 4. State 5. That's why I was getting confused. And then state 6 for checking the bounding box. Cool. So we go. We've read the bounding box. Now we go. We've read the bounding box. And then we have to go. And then we have to. Yep. So we read. Why are we always reading? Oh, right, because we're reading from the same point in memory. And so, yeah, so we read 1, 4, and we shouldn't. Yep, this is the. Let me comment this. This is the read. This is the check bounding box. Check bound box. And so if we check here on the check bounding box state, the bounding box correctly reads 602001. Is that correct? 01. Hold on. Where's the input? Wait, 1, 2, 3. That only ran 3 times. We need to have it run a 4th time. Whoops. NVMe project.v. Yep. If it's 0, 1, 2. Oh, that's the read color. here. 1, 2, 3. If counter equals 3. Yeah, we increment it here and then we check it here. So if counter equals 4, and I'll just like, how much is in a counter? How big is a counter? Counter 2 bits? Nah, a counter is actually 4 bits now. We are burning register space. A counter is actually 4 bits. And then down here, if counter is 4, yep. Cool. Refresh this. This should run one more time. If counter is 4, then we go to check bounding box. Otherwise, we go back to the start here. Yeah. This has to be 5, maybe? Let's just have it permanently going in this loop. Okay. So the problem here is that it's changing state too fast. Counter goes 1, 2, 3. Yep, so counter is 3 during state 5. And yet we go to state 6. Why is it doing that? What is it doing? So the counter is 3 during state 5. And yet it's going to state 6. This is wrong. I should just have it increment the counter here. So it goes 0, then 1, right? And then if the state here is 4, because it goes 1, 2, 3, 4. I'll just have all the counter stuff happen at the same time. Okay, so counter starts at 0. Bang, it's 1 now. 2. Counter is now 3 at the end of the state. Counter becomes 3 here. Why is it changing states at this time instead of... Oh, it's... Whoops, it's because I wasn't updating that. There we go. 1, 2, 3, 4, 5. Okay. It's running too often. This is a problem, so I should set this to 3. There we go. And then voila, yep, we are going for longer. 05, 06. And then it goes to state 10. Which is state 10. State 10 is right color. So this means we're writing black to the screen. Cool. So, check bounding box. We have I'll have 2 pads here. I'll have if counter is 3, we go here. And so, if not in bounding box, we go to state 10, which is right color 1, which is state 10, or A, because hex, right? Cool. And so, check bounding box, yep. During state check bounding box, we do the check, and if it is there, we go to either read or right color. And then, let's go to right color. And so, I need to move this up here to right color. Right color 1. And then, right color 2 does that. And right color 3 is doing the counter stuff again, yep. And so, yep. Yoink that into right color 3. And then, let me just add some new lines to space out. And then, read and write address. I'll handle that over there. If counter is 2, then we go to shape bounding box. We set the current pixel, we increment to 1. Otherwise, we go to right color. That's correct. Default is state 255. And then counter increments here, and then that's the counter stuff. Yep, there we go. And then, cool. Let's refresh that. We go. A, B, C. Cool. What is the problem here? The problem is we're outputting 128 and we're expecting 0. That's not great. That's not a great thing to have happen. And so how are we going to do that? We're gonna... So outputting 8 and... Hold on, we're outputting 128. Why are we outputting 128? When we write color, we write whatever's in the color thing. What is in color? Color is 0. Why are we outputting literally anything? Hold on, does this thing have a light mode? Edit preferences. Review. Oh, I'll figure that out later. Yeah. 20602001. Yep. So then read address. Why is... Hold on. What is failing here? It's line 52 and write to memory. Nvim. Line 52. Asserting, yeah, the output value that we have, right? So we are out mem address, output enable. Yup. The value should be 0 because we should be outputting 0 as the color, and yet right color 1, 2, 3. Yup. Right color 1, we are outputting 0, 0, yup. Right color 2. Right color 2. UO out reg is the color we're writing out. UO out. It should be it should not be at 255. Why is the current color 255? What is going on there? Why is num shapes? Oh, right, because we're skipping out on that. We just assume there's one shape. Yeah, that's whoopsies. Yeah. Cool. And then we have FF and then 8, 0. Oh, that should still be address, right? Yeah, 2. Address and 255, yup. For write enable, output enable. UI out reg, and write address is whatever, it's write address. UO out 80, yeah, that's correct. And then here we are. Right color 3, we should be outputting 0, 0 on UO out reg. And yet we're not. Why? What is our counter at? Our counter where's the counter? It's at 4 because I'm not resetting it. That's the problem. Then here, counter, we're setting it to 0. We go for one more. Go back to the start. There we go. So write address is correct. UO out, all of that should be correct, and then counter turns to 1. What fails here? Where 0 equals what? Write memory. Yeah, okay, that fails. We line 40, okay. What is on line 40? Here. Right, we're outputting the next color. Right, so we're outputting color number 2. Okay, cool. And so we have color number 1. Sorry, we have the green value, which should still be 0. Memory address is bang bang. So clock cycle 1, 2, 3. Yup. Clock cycle 1, 2, 3. Yup. Then we go back here. And then the right address. What is the problem? Line 40. The problem is we're not incrementing the address that we're writing to. And why? Why is that happening? No, we should be incrementing that. Right address plus equals 1 on right color 3. Right address plus equals 1. This is correct. During this state. And so what are we expected to output during this state? The UI in, we don't care. We're not reading that. Then yeah, output enable and out. Sure, they should stay as FF probably. No, why are they not 0 or 1? Why is UO out not 1 now? Because we're getting the last 8 bits. Right, because when we're going to right color 1, we are not doing the right things. Where is check bounding box? Right color 1. We yoink that, and so then when we're doing the bring back, we paste that in there because that's what we do on right color 1. And then I need to paste this back where we're doing this. Cool. Yep, we fail once again. We go further. This is color 1, color 2, color 3, and we go all the way back to state 3, which is the reading of the bounding box, but the current pixel is incremented by 1. This is a great sign. Now, what is the problem that failed here? We should be reading state. Yes, we should be reading 1. And yet we're not. This is because when we jump to the read-shape bounding box, we're not actually jumping to the real read-shape bounding box. Yoink that. Read-shape bounding box. Yup, there we go. Oh my god, okay. Here, this is ugly code that we need to clean up sometime soon. Yep, read-shape bounding box. There we go. Cool. Yep. We go a little bit further. 3, 4, 5. Immediately off the 6. This is because we're not resetting the counter. Read-shape bounding box. Yep. Counter gets it to 0. This means I should move this counter increment down here. Cool. Yep, more failure, but we do keep going. A. So what is failing over here? The thing that's failing over there is in number 1. Okay, forgot to increment that. Whatever. Or 3. Yup. Some random number. What line is this failing on? This is failing on line 40 in write to memory. Okay. So we're failing on line 40 of the write to memory. Write to memory, line 40. 43, 42, 41, 40. Last byte is wrong. What should the last byte be? On... Yeah, it'd be 0A. This one happened. Last byte. Oh boy, what's the mem address? It should be, so it's 128 times y plus x. X should be 1 And so because of that, it should be reading. Why are we reading? Oh my god, it should be 3. This is 3 bytes per, not 1. Okay, so the test is wrong here. Plus, and so this is the offset, and so I have to multiply the offset by 3. I'm going to do the same here. Multiply the offset by 3. Oh, we went until we hit a different point. Okay, so now let me just get rid of my print statements, because these print statements are not useful. Let me print. Hold on. Let me just print the x and y. Let me print x colon x and y colon y. Okay, so the x is incrementing all the way up until 96. What happens when x is 96? Yep. At the very end, 3, 4, 5, 6, 7. Ah, so we entered the valid path. Cool. So like, let me finish up this path real quick. Right color 1, 2. So this is 11 or B. Right, as you can see, it goes A, B, C. I don't care about spacing. And then right color C or 12. And then this is right color of 3. Right? So we go bang, bang. And then since we've written the color, hold on, I should probably just, because we do have to do right color anyway, so I should probably go down here. If not in bounding box, let me move this over here and move this connection over here. And then we have the read color side. So read color 1, which is going to be state 7. Cool. If in bounding box, we're going to read the color from memory. Cool. And so, yes. And so, do I have proper read support? Yep, read from memory, attempting to read from location 5. The problem that's happening here is that when we do read color, we're not actually doing this stuff, so just yoink it, paste it, and then we do the counter stuff. Read color 3, and then the do we change or not, and then here, prior to the teleport back to read color 1, we paste that in. There we go. Read address. And then read address plus 1. And I should probably reset the read address to what it started out here, so because this will fail after one thing. 90. Yep, that passed. That passed another state. 7. Okay, we're reading from 5. Yup. And then, but that should be 6 in theory. Yep. 5 equals hold on. Yeah, okay. Your out.value is mem address 5. Okay. So you read the first one successfully. 6. No, 7 is the one. Let me just finish off this diagram. Right, read color 1 is 7. Read color 2 is 8. And then read color 3 is 9. Color 3 is 9. And then this will just go there. Obviously, there is a cleaner way to do this, which is to move the right 3 down. And then once we write the color, we go all the way back up to the starting state. No, we go back up to read dump shapes 1. Cool. So there's our current loop where we just read the number of shapes, then we read the bounding box, and then write color. This should be going back to read bounding box. Yeah, cool. We are going back to read bounding box, right? Hold on. Yeah, we're going back to read bounding box. Cool. So there's our loop. There's a hot loop. And then from here, yep. From here we keep going, right? So we can have read shape bounding box. Right color, yep. Right color. So now the read color is wrong. Right. So read color 1. We check the read address. So right now we should be outputting 5 and then 0 on the UIO out. UIO out, 5 and 0. This is correct. Why is 5 wrong? You're reading 5 and 3, yup. So we're failing on line 40 on the write to memory. Oh. Oh. Hold up. Right, because the problem is we're not in the box, so... The problem is when we read the, check the bounding box. If the current pixel is less than... This is not... Yeah. It's not in the bounding box. Or... Or is a keyword, yep. Or... Yeah, so this is just checking if we're to the left of the bounding box, because this is just checking the X. Now we have to check and current pixel of 15:8 is less than bounding box of 15:8. What is the problem? The problem is or doesn't exist. Sorry, and doesn't exist. Please tell me it works like C. There we go. Go all the way up to 96, and then we still fail the checks. Hold up. What is current pixel? Current pixel is 0060, so it passes the first check. Oh, hold on. It should be an OR. I am losing my mind. It should be an OR here, not an AND. Whoopsies. Whoopsie daisy. OR. There we go. I need to get rid of these print statements. Or I should only have it print the Y level. And then it fails there. Why does it fail there? Now we are in the proper zone, correct. 32, 32. We attempt to read from 0.5, but... hold on, let me check this. Fresh. A lot of stuff's happening. Cool. State. Check bounding box. Yup. The problem is that we're not weighting the right amount. Hold on. Check bounding box. This should be up here. Cool. And I should probably not. And while I'm in here anyways, I'm gonna get rid of this. And just have it print what Y we're on. There we go. Now we're running. Yes. Yes, there's off lamp. Yup. Cool. 96. Okay. Y is 32, X is 32. 96, and we're looking for 5 modulo. Oh, yes, here is where we fail. Cool. So, we need to be reading from address 5, yes. And yet here, this is not clearly not address 5. We're reading from, like, address 3060 or something insane like that. Cool. And then in the bounding box, check bounding box. Then read color. Read address 7. And what is the value in read address? 5. This is wrong. This is simply just wrong. Read address 70158. Okay. Huh. 7015:8. Read color 1. Yes. And counter 0. Yeah, this is all good so far there. Read address 7:0. In here, we have to deal with the read address. And it should be read address 7:0, which is not happening right now. Read address. Yeah, why is UIO out? Why is UO out? Okay, hold on, let's start with UIO. Why is it 60? Where is that coming from? UO out in read color 1 should be 5. Right? I see no reason why it shouldn't be 5. Read address. Oh, byte address, yeah. Bang, bang, bang. I should probably hold up. Let me add a quick read address 5 in here, just so we have it. Let me get rid of that read address 5. Yeah. Read address, where are we saying read address 1? In read num shapes. Read address. Yeah, so read address starts at 1, and then hold on. Read shape bounding box. We need the read address to be set to 1 here again. That's whatever. We can deal with that later. Did we go through that at all here? No, but 6 right. 6 right. Oh, we're failing on right. But it should be a read. There's the problem. We're going from 6 to here. Yes. Something to write when it should be a read. Less than bounding box is 70. 1020, and then bounding box is so 60. Yup. 60. Yup. Oh, we're only on 20 here. It should be 60. 32. Wait, what? Last bit was incrementing. Yep. Okay, so we have the full gamut of numbers here. One zero two zero. 255. Yeah. Okay. And oh, it's 255 by 255. That's the problem here. Okay. Okay. So not 32. 64. Okay, hold on. Yeah, okay, so current pixel is 16 bits, yep. So then when we're doing the bounding blocks, current pixel, not 7 to 0, 6 to 0. And then here it should be 13 to 7. And here it should also be 13 to 7. Cool. And then we go up to the waves. Oh, we have to wait for this to run. Rip. We gotta wait for it to run. Unfortunate. Yep, and there we go. We failed. 32. We are still on... Still failing on 32. What is the bounding box? $32, 96, 32, 96. Oh, wait, when we're writing the bounding box, it's wrong. NVMSOC. Project.v. Oh, where's read shape bounding box? 2, and then here, yep. Bounding box 6. Then we go to 14 to 7. Yep. 14 to 7. No, 13 to 7. Yep, 13 to 7. And then we go 20 to... Yep. 20 to 14. And then we go 27 to 21. Alright, let's see what happens when we hit to Y32, which is where we care about right now. Yep, Y32, we are still failing. Not all of them, yep. I'm gonna undo that. I can't undo that. Okay, hold on. I know what I did. I will keep this proper. Where's the reshape? Yeah, okay. Let me keep this proper. 15, 23, 31, 8, 16, 24. I'll keep that proper. All right, so we're pumping in the pointers into here. And then when we do the check, we check whether 6 is less than 7. And we check whether current pixel that's the right bound is... That's the X value. That's a problem, right? That was the problem the whole time. So we check whether that is less than that. And then we check whether this is less than... It'd be plus, so it'd be 23 to 16. There we go. Where are we incrementing the pixel? Current pixel is just +1. Yeah, okay. Okay. There we go. Cool, and now we should not be failing at... No, well, we should be failing at 32 because... Yep. 96, are we still going to... Oh my god, okay. Current pixel, 1020. Binary. 1, 2, 3, 4, 5, 6, 7. Yeah. So 1, 2, 4, 8. So this is 32, and then this is 32. Yup, that's 32 and 32. Binary. 1, 2, 3, 8. Wait. 4. 4. Oh my god, we're reading from the wrong bits. Rip. It goes small, big, so... Yep, so instead of 17, it's 15 to 8. And this is 31 to 24. Rip. Now this should work, And we should be able to read the lines up until we hit the point. 32 we fail. 5 is 6. Yes. Bang. 7, 8, 9. Bang. We're not incrementing the read address at the proper point in time. There we go. Where's read color? Read color. Where are we incrementing the read address? We're incrementing it here, which is the wrong point in time. We should be incrementing it here. This takes a while to run. I should probably change it so that the real shape starts at a better spot, but what? Oh, we're going 7, 8, 9, 7, 8, 9. So we read the color, yup. And then A, B, C. Okay, what is the problem here? This is the write to memory. Yeah. Line 52, okay. Line 52 is... The output is wrong. What are we outputting? UO out is... Oh, UO out, yep. UO out 60. So we're outputting the color of 60 when we should be expecting... the color we're expecting is 255. Okay. What's in memory? 255, 255, 255. What are we... 7, 8, 9. Okay, we're not... In read memory, it's not actually reading the right memory into it. Okay, so we're not feeding the chip the right memory. Sure. Read from memory from point 1 to 4. Yeah, we checked the bounding box. Five, 6, right, 5, 6, yeah. And so Y is on 9, we're not outputting here. So read from memory, mem 5, 3. Read from memory, mem address, UN value equals data, because mem input of mem address, yes. Okay, let's just log. Let's just log the data. If mem address equals 5. And then now let's just log the mem. Let's just log the data. Data. Mem address is 5, 5, yep. And let's run that. Let's run it and let's see how it goes. Yeah. Cool. I'll probably stream for another 10-15 minutes at this point. But yeah. I forgot to make an F string. Yup. Forgot the F string. Cool. There we go. Yep. Data is 255. Okay. Dut that uin.value equals data. Dut that uin.value equals data. Ooh. What? We're reading the correct data over there, so why is this one is 255, yep. Alright, color. Why is the first bit of color 60? It's because it's not updating properly over here. So we read. 2060, 2060, yeah. Three, 4, 5. Well, let's go all the way back to the beginning. Two zero six zero 2060. Yep. Okay, and then Why is this? So this problem is up here. What if I just put that? Yeah, so we've asserted that we've read it, and then we change it, and then the clock cycles happen. We read it and then move on. Yeah, okay. Read from memory, write to memory. This is when we actually output it, and then this is, yeah, okay, cool. Six ABC, yep. 7, 8, 9. Still 6, 0. And then read color. Yep, counter is 0, 1, 2. Yep. This is all correct. I guess we can delay this a little bit, right? Yeah, because this would be doing it. Yeah, okay. Because color, we can, it's like a delayable thing. And obviously we have to wait a little bit longer. Error. F. And bang, right back to the beginning. What is the problem when we go back to the beginning? Problem is in line 54. $255 right shift by 8. Oh, my test is wrong. Write to memory. Data. Memory 255 plus 2. It's just all. It's just 24 ones. So 2 to the 24 minus 1. Now theoretically that should work, and then we should be golden. We should have the first shape working. Yup. Oh, we're valid for a whole bunch of it. What's the failure here? 5, 6, 7. Now let me delete the print statements here. Yep. So yep, we're still within the zone. However, we failed in line 95. Oh, hold up. What? Line 95, write to memory 0. Okay, so that's not actually line 95. But the problem is the other side of the condition. Yep. SRC project.v. And then, now then on the other side of the condition, what we're going to do is we're just going to have a few more ors. Or current pixel of 7:0 is greater than bounding box of 7:0, not 7:0, 6:0. And then from here we have a little bit more. We have another OR statement, or current pixel of 13:7 is greater than bounding box of this would be a little bit more than that, so 23:16. Cool. Now let's run it. And so we should pass Y32. We're still failing here. Interesting. Line 93. Where we're attempting to. Alright, what's going on here? We're still going through there. Okay. Huh. Let me change these both back to. Hello? Data format hex. Cool. They're both in hex. Why is the last bit of this FF? It's because here, yeah. So the bounding box should edit at the right time, yeah. Yeah, cool. There we go. 31, 32. Yep, okay, we're still failing this. Problem is, we're not activating at the right time. Now, why is this? Hold on. The bounding box is correct. Hold on, let me change current pixel back to hex. Current pixel 1020. Oh, wait, hold on. This has to be in binary. Yep, so if you cut off last 2 bits, yep, we are. It is the correct number. It is the proper 20. And so the problem is we're not activating here. SOC project V. And so now when we do our checks in check bounding box, where we just do this check, so we know the bounding box is of the correct state. Yes. So the problem is we're failing one of these 4. We're failing all 4 of these is the problem. Current pixel 6, 13.7, 6, 13.7, then 15.8, 7.0 greater than, 23.16, yep. So we are no longer less than this. So we're passing one of these. Right? In this, we are passing one of them. And so 6020, 6020, we should be at 60. So we should be passing, and then, so yeah, we should be failing all 4. 13 to 7, yeah. Greater, yeah. Not in a bounding box, otherwise we are in the bounding box and we read the color. Okay. Bounding box is like correct because that's not changing clearly. Current pixel 6, 13.7, 6, 13 to 7. Yup. Bounding box, current pixel. Okay, what? Current pixel passes any one of these 4. We fail. Hold on. Current pixel of 6 to 0. So the first 7 bits here is 1, 2, 3, 4, 5, 6, 7. Yep, is 32. And yep, that would be 32. Yep. So that passes. And I mean, it's passed. There's been times where it's passed and passed. So the problem is the Y checking. And we're obviously failing on the smaller than the 6, 0, right? Like, hold up. Let's just have that and let's see if we fail there. And then if we do fail there, that's a good sign. Yeah, okay, we are failing at that spot in the exact same way. In the exact same way. Yep. Okay. So it's not that. Oh no. I don't have bet on new history. I will deal with that later. Yeah. The problem was I moved this bounding box thing here. Where the UI in... Yeah, I mean, the bounding box is fine. We know the bounding box is fine here. Check bounding box. We're not going to the right spot. if current pixel, which one of these is failing? Okay. So both of these should be 0. That's state 6. We're going to state A, which is write color, which we're going to state read color. So this means that both of these should be false. So what this implies is that both of these are not false. 3, 2, yeah, okay. So it goes Y, then X. And so, yep, current pixel. Bounding box is less than the... Oh, wait. These numbers are flipped now. Oh, come on, man. So the correct answer... Yeah, okay, sure. Okay, sure. This was 7 to 0. 23 to 16. They got flipped. They got flipped. This is so sad. This is so sad. 31, 32. And the problem is when we're trying to rewrite 0. Yup. Okay, let me finish off the X here. Or current pixel of 6:0 is greater than bounding box of 15:8. Yep, 15:8. Or, and then, or current pixel of, this would be 13:7 is greater than the bounding box of 31:24. Cool. Now let's run that, and hopefully this works. That's a very good sign. We might actually have a render. Now let's see what happens after 96. If it's seeing after 96. Oh, we have properly rendered the image. Let's go. We've rendered an image. Now we need to be able to display this image. Now we need to be able to display this image. Let's go. PPM file format. Okay. There we go. PPM file format. P3. Yep. So this is a 3x2 image. So we start with P3, 3x2, 255. So we go R, G, B. Okay, cool. There we go. So now we have the image in the output, right? So it's mem.output. And then I'll have a function up here called def show write output to ppm, and I'll ask for file name. So yeah, self comma file name, yep. And then yeah, so for cell, and so out text equals, and so let's just follow the format from Wikipedia. It's P3 new line 255 new line, and now we just go pixel by pixel, and then hold on, 3 2 1, using the same image width of 3x2 and using 0 or 1 per color, red, green, or blue. White space, it just doesn't matter. Okay. So then, yeah, I'll just use new lines. And then for yeah, it's an output size. So what's the output size I set here? memory. Where's I saying memory? 2 to the 16. Okay, sure. For I in range, and so this would be 128 by 128. So 128 by 128. Yeah. So out text plus equals f string of, so it ends with a new line, 2 3 self dot output of, and we will be asking for 0 self dot output of I times 3. Yeah, and then here self dot output of I times 3 plus 1, and then self dot output of I times 3 plus 2. And then I'll just like dump it. Open file name, comma, write dot write, and then it'll be out text, and then I'll, yeah, mem dot out write output to ppm, mem dot write output to ppm, and I'll call the file single shape test dot ppm, single shape test dot p3. What's the file format for this? Dot ppm. I'll just call dot ppm. And then hopefully we might be able to render an image. I should probably edit the goal. Goal. Render shape. And then dumping is suppressed. We passed. Where's the P3? Single shape.ppm from single shape test.ppm. Google Chrome stable. Single shape test.ppm. What's an image viewer? Hold on, let me. Sure, ppm. Yep, a simple one. Files. Test. Max colors is not 255. What? 255. Oh. P3 255. Oh my god, I need a space. Yeah. Whoopsie daisy. Alright, let's re-render this. Let's re-render this. We're so close. We're so close to being able to render. We're so close to being able to render. Oh my god, it's gonna be so good. It's gonna be so good. We will be able to render the image. Okay, okay. Are we popping off? Are we popping off? Maybe. Hold up. Okay. Choose file, ppm, select. Max colors is. Yeah, there's the problem. Let me double check the format. I need the, 128, yeah. Alright, let's render it again. Let's render this again. And then we should succeed. We're close to success. Okay, okay. Doo-doo-doo. Almost, almost. Come on. Okay, there we go. PPM viewer, refresh, choose file. There's the image. Let's go. The image has popped up. We have rendered a shape. We have successfully rendered a shape. There we go. Now let's change the color of the shape. Instead of being 255, 255, 255, have it be 255, 128, 0. Let's have it be a, you know what? RGB. The B should be 128. A nice, mostly red-ish color. Might be like a magenta. If this works, it will be truly amazing. Oh, we failed. Whoops. What's the problem here? Yeah, okay, the current pixel is fine. What? Where's the color? What? Oh. Yeah, okay, cool. So the color is... The problem is my test is wrong. Rip. R equals 2... I'll just say color equals 255, 0, 128. Then put color of 0, color of 1, color of 2, and down here I'll just color of 0, color of 0 times 255. Sorry, times 256 plus color of 1 times 256. Hold on. There we go. Times 256 plus color of 2. And hopefully this works. Whoops, bad testing. Bah. 255. So we're outputting 255 and we're expecting... Come on, man. Alright, I'll just have it be like this and fix my test case later. Oh well. Oh well. We succeeded. We succeeded. We have succeeded. The image is out. That is a great success. I will see you all next time. Goodbye.